Guys, today we are going to talk about recursion, and I'm going to start by introducing a very famous joke about recursion. So it goes like this. So to understand recursion, you must first understand recursion. So it does not make a lot of sense, but once you understand recursion, I swear it is going to be funny. So let us see what recursion actually is. So in the most simplest sense, in case of programming, recursion refers to a program solving technique in which a function calls itself. So a function calls itself, and we can use recursion to solve various problems. One of the problem that can be solved by using recursion is a factorial of a given number. So we all know the factorial of a given number can be computed by let's say if you want to compute the factorial of 4, we can compute by multiplying 4 up until 1. So 4 into 3 into 2 into 1, that will be 24. So in the same sense, we can define the factorial of a number recursively. So first let us set a base case. So 0 factorial will be 1. So we can define 1 factorial as 1 into 0 factorial, so it will be 1. Similarly, we can define 2 factorial as 2 into 1 factorial. So in the same manner, 3 factorial as 3 into 2 factorial, and you got the gist. 4 factorial as 4 into 3 factorial, and finally we can conclude that the factorial of n is given by n into n minus 1 factorial. So the pseudocode of this program is going to look like this. So we are going to create a function. It will accept a parameter called n. If the value of n is equal to 0, it is going to return 1, and if the value of n is something else, it is going to return n into the same function with an argument that is n minus 1. So now let us try and implement this pseudocode in our C program. Let's just start our programming by writing a program to calculate the factorial of a number recursively. So what I want you to do is that I want you to open your favorite IDE where you can code C program. So I want you to create a new file, and then I want you to save that file somewhere. So I'm going to save my file in desktop, and I'm going to name this file, let me call this file uh, rfact.c. So then I want you to include the necessary header file as usual. So we are going to include stdio.h, and then let's create a function called factorial, or we can just call it fact, and it accepts an argument of n. So let's write our base case. So if the value of n is equal to 0, if the value of n is equal to 0, then we are going to be returning 1. If the value of n is something else, then we are going to return n into the same function fact with an argument of n minus 1. So you can see how we define the factorial of a number in terms of itself. Here I will return 1 if n is 0, otherwise I'm going to return n into the same function with n minus 1. So this is how we do this. Now let's create a main module. It's very simple. Let us define a number, and then let us ask for a number from the user. So let us ask for a number using normal procedure in C. Then let's store that number, let's say in the variable we declared earlier, that is number. Then we can just print the factorial of number as follows. Factorial of percentage d is, we can use percentage ld for our long integer, which is going to be returned from the function. Then I'm going to be displaying here number, and then I'm going to call my fact function with an argument of number. So what happens here is that in the place specified by percentage d, number is going to be shown, and in the place specified by percentage ld, factorial of number that returns from this function is going to be shown. Let's save the program. Now let us run this program. So I'm going to open a terminal. I'll use GCC compiler to execute the code. So I'm going to go to my desktop where I save this code in the name of rfact.c. I'm going to use a compiler. This is a compiler, so I'm going to compile this code. rfact.c -o. Let me compile it to rfact. So it compiled without any errors. Then I can run this program with /rfact. So let's say the number I gave 5. You can see that the factorial of 5 is 120. So this is how we can calculate the factorial of a function recursively. If the number is equals to 0, we return 1. Otherwise we return n into fact minus n into fact with an argument of n minus 1. We're going to look at another application of recursion. So we are going to look at an ancient puzzle called Towers of Hanoi. So in these puzzles, the rules are pretty simple. You can only move one peg at a time, and another rule is that you must keep a smaller disk on top of a bigger disk. That is, you cannot keep a bigger disk on top of a smaller disk, and the goal is to transfer all the disk from the first peg to the third peg. So this is our goal in this ancient puzzle. So let us see the solution to this ancient puzzle. So whenever the value of n is equal to 1, the case is very easy. I can simply move disk number 1, which is this disk in this case, from this peg to this peg. Let's call this peg a source peg, this peg a temporary peg, and this peg a destination peg. That is, I can simply move my disk number 1 from source peg to the destination peg. So minimum number of moves is given by 2 power n minus 1. In this case n is 1, so the power 1 raised to 2 is 2 minus 1 will be 1. So similarly, if the number of disks is 2, we can calculate the minimum of moves as 2 to the power n minus 1. So 2 square is 4, 4 minus 1 is 3. So it is very easy. So in the same manner, we have to move this disk number 1 from source peg to destination peg. That is, we move this disk number 1 from the first peg to the second peg. So after moving this, the game tower is going to look like this. Then we will move this disk number 2 from first peg to third peg. So we moved it from the first peg to third peg. Now we can simply move this disk number 2 from disk number 1 from second peg to third peg. So I moved the disk number 1 from second peg to third peg. Now all my disks are transferred from the first peg to the third peg. So this is how I do it for n equals 2. Now the solution to this problem is pretty easy using recursion. So we are going to create a function called TOH. It is going to accept 3 parameters: source, destination, and temporary, and where n is the number of disks. So if the number of disk is 1, we just move the disk from source to destination. So I hope you understood from this example. If the number of disk is 1, you can simply move it from the source to destination. So similarly, in the next case, if the number of disks is not equal to 1, if it is something else, what we do is that we transfer the n minus 1 disk. We transfer the n minus 1 disk from source to temporary using destination. So let's see what this means. So in this case, n is not equal to 1. So what we do is that we transfer n minus 1. That is, in this case 2 minus 1 is 1. We transfer one disk from source to temporary using destination. So we transfer this from source to temporary using destination. So you can see I transfer this. So after transferring the disk from source to temporary using destination, now my nth disk is free to move. So I can simply move this from source to destination. So that is what I have written here: move disk n from source to destination. And at the last, at the very end, I can transfer this n minus 1 disk from temporary to destination using the source. And this is what I will do here. I will transfer the n minus 1 disks from temporary to destination using the source. So this is how we implement Towers of Hanoi. So let us look at the programming implementation of Towers of Hanoi using recursion in C. Guys, now let me show you how you can implement the Towers of Hanoi program. Okay, so let's open your favorite code editor. Then let's create a new file with an extension of C and save it anywhere you want. I'm going to save this in my desktop with an extension of .c for C files. After that, I'm going to include my normal standard header file, which is a stdio.h. Then I'm going to create a function called, let's call that function TOH for tower, short for Towers of Hanoi. So we are going to give it some argument. So let's give the same argument we use our algorithm, we devise our algorithm on. So we are going to give it source, we are going to give it destination, then we are going to give it temporary, and then we are going to give it an n, where n is the number of pegs. So rule is quite simple. If n is equal to 0, if n is equal to 0, then that means there is only one peg, sorry, haha, this happens. So if n is equal to 1, n equals to 0 does not make sense. I don't know why I thought about that. So if n is equal to 1, then we just have to move that disk. If n is equal to 1, then we just have to move a disk from source, move disk n from source to destination. So this is what we do, and then we give it a parameter of n, and then source, and then we give it a parameter of destination. So we can see here this n, the value of n is going to be displayed here, the value of source is going to be displayed here, and the value of destination is going to be displayed here. Otherwise, if there are more than one disk in the pegs, so what we do is that we call the same function with an argument like this. We want to move from source to temporary using destination n-1. We want to move n-1 disk from source to temporary using destination. Now we have moved n-1 disks from source to temporary after the execution of this function call. So then we move the remaining disk from source to destination, because all the n-1 disk on the top of it are already moved at temporary in the function call that happened just before. So we are going to move the n disk from source to destination. So after doing that, we can move the remaining disk which we move to temporary in this step to destination. So what we are going to do is that we are going to use the same function call. Now the disks are located in temporary, and then we are going to move them to the destination using our source, and there were n-1 disk in the temporary node. So we are going to move that n-1 disk from temporary peg to the destination peg using source peg. So this is how we implement the Towers of Hanoi program in C. So this is our function. So let me see what I have done mistake here. So okay, I added an extra inverted comma over there, so it's fine now. Let us make a main module, and let us just return an empty variable for our int, and then let's call the function Towers of Hanoi, TOH. The source peg is A, the destination peg is C, and the temporary peg is B, and we are going to be moving 3 number of pegs. We can do this. So if we want to be more versatile, what we can do is that we can ask for a argument here. So we can define n, then we can ask for n from the user. So enter number of pegs, enter number of pegs, and then we can store the number of pegs uh, in a variable called n, and then we can just call the Towers of Hanoi on this thing. So in this case our source is a, that means the first peg is a, second peg is b, and third peg is c. So do not be confused here. We are calling this from like this, from where we want to move n disks from source to destination using a temporary peg. In this case the source peg is a, in this case the destination peg is c, and in this case the temporary peg is b. So this is how we do our program. Now let us see and our output if it's correct or not. Okay, to run my program I'll click open my terminal, and then what I'm going to do is that I'm going to navigate to desktop where I store my program. Okay, I'm going to navigate to desktop, I beg your pardon. So after navigating to desktop, I have a file there called tos.c. so I'm going to compile that file like this. So once that file gets compiled, I'm going to run that file. So it asks for number of pegs. So if I enter 1, you can see that it says move disk 1 from A to C. So if I have 3 pegs, then I can simply move disk 1 from A to C. So let's repeat this for let's repeat this for 2 pegs. So we want to move the first peg from A to B, then we want to move the disk 2 from A to C, then we move disk 1 from B to C. Now let us check our final solution for the n equals to 3. So we can easily do that by just giving 3 as an argument. So what we do here is that we move disk 1 from A to C, then we move disk 2 from A to B, then we move disk 1 from C to B, then we move disk 3 from A to C, then we move disk 1 again from B to A, then we move disk 2 from B to C, then we move disk 1 from A to C, and this is how we solve the Towers of Hanoi problem. So if you understood, if you learned something, smash that like button, and don't forget to subscribe for my upcoming videos. Thank you.